All right, folks, so we're going to start in the homework packet on page 7. And there's a few of these that I would like to go over. First, on number 2, just be careful on this one because what is my LCD?
2x, no, x plus 2. 2 times x. 3 times x.
2 times x plus 2. So it has to be multiplication because I cannot just add x to the top and the bottom of this. I have to multiply by a creative form of 1. So your LCD for that one would be 2 times x plus 2. And folks, on the test, I am going to ask that any problem that requires the LCD, you explicitly state the LCD. All right, folks, we're going to go ahead and go through number 4 together. Identifying our operations first. We've got an equal sign. We've got subtraction. Number 4 on page 7.
On the homework form?
Yep. So what do you want to do first before we find the LCD? Let's float the negative up with the numerator so we don't forget about it. Next, the LCD. Now, x minus 6, that's its own factor. X minus 8, that's its own factor. How do you think we're going to be able to factor that quadratic? X minus 6 and x minus 8. So then my LCD is x minus 6 times x minus 8. So that's what we're going to use as our dynamite to destroy all of our denominators. But before we start destroying, what restrictions do we have on x? 6 and 8. 6 and 8 make all of the denominators equal to 0. So x cannot be 6 or 8. All right, folks, you can either do the box method or the covering up method. I'm going to do kind of the shortcut method here. So if I multiply the first fraction by the LCD, goodbye x minus 6, goodbye x minus 6, and we're left with 5 times x minus 8 equals, looking at my second fraction, if I multiplied that by the LCD, the x minus 8s are going to cancel, and we're left with 14 times x minus 6. What am I left with after I multiply the last fraction by the LCD? Just negative 82. So 5x minus 40 equals 14x. Oh boy. And then a negative 84 and then negative 82. Ooh, we're going to add a nice big number there. That gives us negative 166.
I have a question. If they both on the other side, it's x over x, and like 1 over 1, if they equal the same, like top and bottom, and how they equal the same.
Yeah.
Well, if like there's 2 of them on opposite sides.
Which one are you looking at?
7.
So your LCD for 7 would be x plus 3, just 1.
I know. X plus 3 and 1.
Mm-hmm. Yep, just 1x plus 3. So when you multiply through by x plus 3, that's going to level out the first and the last fraction, but you'll have to take negative 5 and distribute the negative 5 to x plus 3. Okay? So that's why when I encounter a constant like that, I always like to put it over 1 to think of it as like a fraction as well. So you do have to multiply every part of the equation by the LCD. So then we've got negative 40, going back to this problem, and 14x, and then minus 166. So subtracting 5x, and then adding 166. Get 126. Gross. 14. Hey, came out nicely. Love it. But before we put a box around it, what should we do? Check it against the restrictions. So 14 is not 6 or 8. So that is not an extraneous solution. It is an actual solution. All right, folks. Questions on that one? The last problem that I want to go through is number 9 on page 8. Now, upon just glancing at this problem, we've got addition, we've got an equal sign. You might be tempted to do this, and say that your LCD is 2x plus 2 and x plus 1. Anyone tell me why that is not the LCD? Yes. Wonderful. So I can take a GCF out. So big letters by this GCF. We always check for a GCF first. And folks, that makes this problem so much easier. We don't have to FOIL anything crazy anymore, like we would have if we had used the wrong LCD. So using that least common multiple, least common divisor, least common denominator is important. So our LCM would be 2 times x plus 1. What restrictions do we have on x? It can't be -1. All right, folks, that is it from me. You guys have the rest of the time to work. If I see you not working, I'm going to want to see that homework packet in full. Okay?